Hi guys, today I'd like to record a quick demonstration of a bash script that I've written to automate the process of recording tech tutorials like this one. So if we come up here we can see that I'm running this script just now, and the video that you'll hopefully be watching is going to be the output of this script. So we can see that I've provided one command line argument here, the value 7, and that's going to correspond to the amount of minutes that I'm recording for. At the moment, I'm not using any sort of keyboard interrupt to allow the user to stop recording. That's a feature that I'll add in subsequent versions. So at the moment, I'm just essentially specifying how long I'm recording for at the beginning of running my script. So if we hop over to this terminal and we use the cat command to output the contents of this script, we can have a look at what it's doing. So first of all, we're using a shebang line to tell the operating system to use our bash interpreter to execute this script. That's going to be located in the bin folder of our Ubuntu operating system. And then we're going to check whether the user has provided the correct amount of command line arguments. So if the amount of command line arguments is not equal to 1, then we'll print a message that says that the correct usage of this program involves the script name. So $0 is going to correspond to the first command line argument, which will just be the name of our file that we're running. And then we'll tell them that they need to provide the duration in minutes. And if they haven't provided that, we'll exit with an error code of 1 to tell the operating system that we did not manage to successfully execute this script. Then we'll create a duration that is going to, this will be a variable that's going to correspond to our command line argument that we specified for the amount of minutes multiplied by 60, and that will give us the total amount of seconds that we want to record for, which we can then use in our subsequent ffmpeg commands down below. So the next thing that we'll do finally before we start recording is to remove any files that might be left over from previous runs of this script. So eventually our two ffmpeg processes are going to produce these two files as output, and then we'll use a final ffmpeg process to splice these two together into our output.mp4 file that will eventually be our finished video. So after we've done all of that, we can start recording the screen with this ffmpeg process here. So the ffmpeg command is going to specify the format, and this x11 grab will correspond to the default format for Unix systems when capturing screen visuals, and then we will specify the dimensions of our screen with this here. So this is a shell command or sequence of commands essentially embedded in this ffmpeg command. So this is going to execute and provide the value of that will then be evaluated with this -s flag. So xdpy-info will give us some information related to our current system, and we'll grep the output of that command for a line that has dimensions in it. And then we'll use awk to extract the second part of that line, which will give us our screen resolution. Then this -i command is going to specify the hardware interface that we'll use for capturing the screen recording. So 0.0 will correspond to the default device on our system, which will just be our screen. Then we'll set another format, but this time it's going to be for our audio. Okay, so ALSA will stand for Advanced Linux Sound Architecture, and that's going to also specify an interface. This time it will correspond to our digital microphone, at least on this system. So that will be how we record our audio into the video. Then here we'll specify the video codec. So this will be a generic video codec that we can use for producing our MP4 output files. And then we will specify the audio codec that we're going to use to just make sure that we have audio that will work on a wide range of systems. Okay, then this preset flag with the ultra fast argument is basically going to tell ffmpeg how to prioritize the compression process. So it's going to emphasize speed over compression accuracy, I believe, with this flag here. And finally, we're setting the time that we're going to record for with this -t flag, and we're using our duration variable that we created up here and that the user provided as that command line argument. Then we'll tell them the name of the file that we want to output, and finally this ampersand symbol is going to tell our operating system to run this ffmpeg command in the background so that we can continue executing other commands without waiting for this to finish. We want to start this command to run at basically the same time as this first command. So this if statement here is going to check, sorry, I should say that this $! is a special identifier in shell scripting used to get the process ID of the last command that was executed as a background process. So we're going to save the process ID of this ffmpeg command into screen process ID, and then we're going to check whether that process ID is still running. If it isn't still running here, it means we failed to start this process, so we'll just exit. We don't want to continue with our script if we're not actually recording the screen and audio here. Then we'll start another ffmpeg command, but this time it's basically the same thing but for the webcam recording. So we want to record video from our webcam at the same time as our screen and audio recording. And we'll output this using the same duration to another file called webcam.mp4. And again, we'll check if that's still running before we move on. Here we're waiting for both of these processes to finish before we move to our final step, which is where we're going to use ffmpeg again to combine these two files into a final file that overlays our webcam recording on the screen recording, and we'll output that to output.mp4. And that's the end of our script. Thank you very much for watching. Cheers.